Hello, we are group number 4 and our topic are smart lighting system.
I will be presenting about the background study. The smart lighting system allow to optimize the energy use, improve the public safety, and support the data-driven decision-making. For example, at night, smart lights can become brighter in high traffic areas, making the driver safer. Other than that, it can dim lights in quiet areas to reducing the light waste. The idea of smart lighting system is not new. Everything kicks off with a basic dimmer and timer. LED lights that were energy saving were the next big breakthrough, opening the door to lights that could be connected to the internet. Finally, there is the rise of the IoT with its affordable sensors and effective wireless connectivity, and this is what makes today's smart lighting system possible.
So the problem statements for our topic is that for ordinary street light, it will always operate at full brightness throughout the night, while when during the day, it will not turn on even if the environment is dark in situations such as raining. And finally, there are no extra values for using the street light for the governing bodies, as the street lights just simply provide brightness. Therefore, for our objective, we want to develop a system that utilizes cloud technologies to provide adaptive lighting abilities to street lights, and also allow governing bodies to easily access and analyze traffic information based on the data collected by our smart lighting system. This is the architecture diagram of our proposed system. As you can see, we have used a total of 5 different services: the Amazon SageMaker, AWS Lambda, Amazon IoT Core, S3 buckets, and also QuickSight.
Now I will present the literature review comparison of cloud technologies. First, let's look into the Amazon Web Services IoT features. AWS IoT first features is secure communications between device and AWS cloud. Second features of AWS IoT is scalable infrastructures, supporting billions of devices and messages. The third features is built-in security to ensuring secure data exchange at every step, such as encryptions, authorizations, and authentications. After that, let's talk about the AWS IoT key services. First key services is FreeRTOS. It's an open source real-time operating system for managing device. Next key services is AWS IoT Core. It's a facilitate secure communications between device and applications on AWS cloud infrastructures. The last key services that I want to present is AWS IoT Analytics. It is a managed service conducting advanced analytics on IoT data. After that, I will present another cloud technologies, which is Azure IoT. Let's begin with the features, which is Azure IoT is a managed app, platform, and platform services options. Managed app platform can reduce the amount of decisions to get solutions more quickly, and platform services offer every component needed to create a specialized IoT applications. Lastly, I will share about 3 key services of Azure IoT. First is the Azure IoT Hubs. It manages cloud services for securely connecting and monitoring millions of devices. Second is the Azure IoT Edge. It allows executing and monitoring containerized workloads at the edge. And then the third key services is Azure IoT Centrals. It manages services platform to simplify IoT application development and management.
Good day everyone. Now I'm going to talk about the Google Cloud IoT. Google Cloud IoT acts as a bridge between the physical and digital world, enabling the secure data transmission between the IoT device and cloud-based application. With the compatibility across a wide range of devices, business can seamlessly integrate IoT solutions to optimize their operation and enhance customer experience. Key services like Cloud IoT Cure provide a scalable device management, while Cloud IoT Edge extends the capabilities to the edge of the network for real-time processing. Cloud PubSub, Cloud Function, and BigQuery offer a robust data processing and analytics, driving innovation and efficiency. Cloud Device SDK simplify the development, supporting the multiple programming language for flexibility. With edge computing capability, organizations can deploy analytics directly on the IoT device, reducing the latency and optimizing the operations. Next, let's compare the cloud technologies reviews, which are AWS, Microsoft Azure IoT, and Google Cloud IoT. All these platforms offer managed cloud service and support a wide range of IoT devices. This versatility allows business to integrate various IoT devices into their deployment seamlessly, regardless of the device type of the manufacturer. They excel in scalability, allow seamless deployment from small to large-scale projects. Whether you are deploying a few devices or million or billion of devices, all these platforms can handle the scale, ensuring the optimal performance and reliability of the IoT application. In terms of programming language support, all of them can support a wide range of language. This flexibility allows developers to choose their preferred language, making it easier to develop and deploy the IoT application on this platform. Edge computing capabilities are available across 3 platforms, enabling real-time processing at the edge of the network. When it comes to the analytics and data processing, each platform will provide a powerful tool for deriving insight from the IoT data. Additionally, they all provide a pay-as-you-go pricing model for cost efficiency. So the difference in the price will based on the pricing tier and discount offered by the different platform. So next, I will pass the presentation to my teammates. Thank you.
And I would like to share with you about the future works for smart lighting system. There are 3 future works for our system. First is energy efficiency. Our system can be turned into energy saving mode by adjusting the strength of the line when the sensor data shows that there is no traffic at the time. Second, the integration between our system and the traffic light system, where the traffic signal can be adjusted based on the conditions that sensor collected. Third, once the collected data is big enough, then air modeling is suitable to be used, and the traffic management system will become fully autonomous. And that's all for our future works, and thank you for listening.
So for Amazon IoT Core, it is used to manage IoT device communication, authentication, and data processing. And so for our setup on IoT Core, we first go to the IoT Core homepage to do our settings. We create a things for our device to connect. And these are the steps of the creation. So we just give the things a name and also generate a new certificate. These certificates are used for connecting with the IoT Core from your device. And also we need to provide a policy for that certificate so that it could perform action on the AWS platform. And when we finally created the thing, it will generate all those certificates and keys. So, and we need to download it now, especially for the public and private key, since this is the only time we can download this key file. After things are successfully created, we use the IoT SDK to create the coding for things to operate. And for our group, we are using Python as the language to generate. So first, we have to store those keys and certificates in a folder that we will be using to access. And for the library, since we are using Python, we have to install the package into our Python environment. And then we will create a Python file, which I have already created, called the PubSub test for testing our device connection to the IoT Core. And these are the coding that I've used for the Python code. And also the endpoint of the IoT core can be found in the settings. This is used in the code as seen from above here. We are using the endpoint here. And just for testing the coding, we could use the MQTT test client on the IoT core service page to see if our messages are successfully being published to the IoT core. And these are screenshots for when the demo is used.
Now I'll present the setup of Amazon Simple Storage service as known as Amazon S3. First, click on the search bar on the top of the page and search for S3. Then click the S3 service. Then click on the Create Bucket button. Next, key in the bucket name. In this scenario, I will key in Smart Lighting System as my bucket name. After that, leave other things at default and click Create Bucket button. Next, in the bucket page, click the hyperlink that created just now. Next, click the Create Folder button to create a new folder in the bucket. Lastly, key in the folder name that you want and then click the Create Folder button to create the folder into your bucket.
Hi, it's me again. In this project, I will be in charge of Amazon SageMaker, which is used for machine learning. But how to use it? First of all, search for SageMaker and click on it. Then select Notebook Instance. Click on Create Notebook Instance and provide all the required information within it. After a few minutes, the notebook will be in service. Then select Open Jupyter Lab. The web page will redirect to another page. In this case, select Conda Python 3 under the notebook category. Finally, you can start coding the machine learning process in Python language.
Good day everyone, now I'm going to talk about the AWS Lambda, which is a serverless compute service provided by AWS to run code without the need for provisioning or managing servers. With Lambda, we can focus on writing our code without worrying about the underlying infrastructure. In our architecture diagram of Smart Lighting System, when the sensors detect activity, they will send the data to Amazon IoT Core. Then the data will be sent to the Lambda for processing. Then it will trigger an inference with Amazon SageMaker, where the SageMaker will predict how much further ahead to light up and the duration. Then this prediction will be converted into instruction using Lambda, and it will be sent back to the IoT Cure and the S3 bucket. Then the IoT Cure will send the instruction to the light to adjust their brightness and duration accordingly. After the data being sent in S3 bucket, the Lambda will retrieve the data from the bucket in the JSON format. Then it needs to be converted to the CSV format using the Lambda, so it can be used in the Amazon SageMaker to train a new model. Then same as the previous flow, if you make a prediction and the prediction will be converted into the instruction in the Lambda and it will be sent back to the IoT Cure, then the IoT Cure will publish the instruction back to the light. So next I'm going to show how can we access and use the Lambda function in the AWS. So beside the service, we need to search for the Lambda. Then we need to select function, create function, then select author from scratch, define a name. Then for the runtime, maybe we can select Python and the architecture. Then we create and access the execution role by using an existing role created before or create a new role. Then we can select create function and the function created will display here. For example, the process sensor data from the IoT Cure. So here we can write our code. So here we extract the sensor data list from the event, which contains sensor data object received from the Smart Lighting System. Then here we initialize our S3 client using the Boto client. This client is used to interact with S3 to store the object. Then for the Sensor data processing. For each sensor data object in the sensor data list, the function will convert the device ID to an integer for the consistency. Then it will generate a unique key for storing the sensor data in S3. Then the sensor data is uploaded as a JSON file to the specified S3 bucket. Then if we want to test the function, we can configure a test event, create a new function, define the name, set it whether it's private to the event creator only or shareable within the user within the same account who have the permission. Then we can write our JSON file code here. Then we save it and we run the test to test whether it is functional or not. So that's for all for me with the Lambda. Thank you.
To store the message into the other services and also trigger the Lambda function for the further actions, we could set up IoT core rules. The rules is used to automatically perform certain actions when messages of predefined topics are received on IoT core. And so for creating the rules, we go to the message routings and select the rules in the IoT core homepage, and we just press create rules, and we just need to give it a name and description. The SQL statement will be used for selecting what message you want that particular rules to perform actions on. So for example, we want to store the light triggers information into the S3 bucket. So we choose select all from the light triggers topic. And then we have to select the action, which can be seen here. For our actions of storing to S3 bucket, we just select the options of S3 bucket, and we need to provide a detail such as the bucket URI and also what folders and file name you want to save the information. And after everything is correct, we just press create, and the rules will be created, and it will be triggered whenever a topic is set, whenever a message is sent into this topic. And similarly, to store the light instructions, we perform the similar actions to create rules for it. And while for the triggering Lambda, for the rule actions, we have to choose send a message to a Lambda function, and just select which function you would like to be triggered. And after that, the other steps are just all similar. And now I will show a demo of the code running. And for the demo, I've already set up for the MQTT test client to subscribe to the two topics that the message will be going through. For now, I will execute the code. And you can see it is connected to the IoT core, and it will subscribe to the topic of light instructions, which are meant for getting the instructions back after going through the inference. And you can see we've published message to the light triggers topic, which is the sensor info collected from the street lights, and we will receive the instructions back from the IoT core, which tells which light has to light up for how long. And we can see from the MQTT test client here, you can see the message are being passed into IoT core, both for the light triggers and the light instructions.
And now I'll show you about the setup of Amazon QuickSight. So first of all, Amazon QuickSight is a visualization tools that allow users to output their data with a graph, making it easy to be read than the fully planned test. And first, we go to the database console and select QuickSight. When it comes to a QuickSight page, if you want to generate a new graph, click the right hand side, new analysis, and then after that you can just click the new data set, and in here you need to choose what is your source input. For us, in our assignment, we use S3 as our data source, so we select S3. After that, we name the data source as Sunlight System, and then we input a QuickSight S3 manifest JSON file. Inside the JSON file, we have two things. One is file locations and one is global upload setting. So we can set the file locations that where is your data and where you want to tag it up. And also the global upload setting is we use the JSON form to upload our data. After that, after you click the connect, then the summarize of the dataset collections will be pop up like this. And then you just verify it and click the visualize at the right hand side. Then you just select the left hand side interactive shift and remain the default options below and click the correct. After you click the correct, you will move to this page, and as you can see, there's three data in the left hand side, which is client ID, date and time, and also light intensive. These three that what we store in our file location that we show in the JSON file just now. So in here, we will put the client ID to the small multiples, and also date and time to the y-axis, and also light intensive to the value, which is y-axis. After you complete that, and in the SSA, you can make the configuration like sort by date and time. Sort order, you make it as ascending, and also the format, you set it as text. So after we set up the SSA, when it comes to a value, we can set it as aggregate is sum and show as number, show on the left axis, and also format, we can use it in no decimal, and if you want the decimal, you can put it one decimal place or two decimal place. It's up to you. After that, this is the complete output that we will generate once you have complete the step of previously that I mentioned just now. So that's all for our Amazon Quick Site setup. Thank you.